This lesson is pairs of angles. We're going to identify several special angle pairs, how they work together, do some more angle addition. So let's get to it. First type is adjacent angles. This is a pair of angles with a shared vertex and common side but do not have overlapping interiors. The best way to describe this is two slices of pizza that are right next to each other. So this example, angle 1 and angle 2, they share a vertex D and they have a common side, ray DB. These angles are not adjacent, even though they touch. Angle 4 and angle 3 touch a little bit right there. They are not adjacent. So angle 1 and angle 2 are adjacent. Angle 3 and angle 4 are not. And another thing to point out is that angle 1 and angle ADC are not. Because even though angle 1, and we're looking over here, angle 1 and the big angle ADC, they have point D as the vertex, and they have side AD as a shared side, they can't overlap. No overlapping. So these overlap. One angle here and then the big angle, all this part in here is overlapped. So that can't be. Complementary angles. That's a pair of angles whose sum is 90. A pair of angles whose sum is 90 degrees. Here's some examples. These two angles together form a right angle, and since a right angle is 90 degrees, these angles are complementary. And they're adjacent. You can have adjacent complementary angles, but they don't have to touch. They could still, if you define their measures, angle 2 has a measure of 50 degrees and angle 1 has a measure of 40 degrees. 50 and 40 add up to 90. So they don't have to be adjacent, and they can still be complementary. Supplementary angles, that's a pair of angles whose sum is 180 degrees. Sometimes it's hard to remember the difference between complementary and supplementary, but C is before S in the alphabet, and 90 is before 180. So C complementary, that's 90. S supplementary, that's 180. A pair of angles whose sum is 180. They could be adjacent, like this. 180 degrees is a straight line here, a straight angle there. And when that happens, it's called a linear pair. When you have adjacent supplementary angles, that's called a linear pair. Because when you put them together, they form this straight line. And the angles that form a straight line always add up to 180. 180 degrees in a straight line. But they don't have to be adjacent. They could be some other way, not touching. If measure of angle 1 is 40 and the measure of angle 2 is 140 degrees, those add up to 180. So they're supplementary. But if they are adjacent, we call them a linear pair. Vertical angles. Angles whose sides form opposite rays. And the best way to see that is in a picture like this. They make a bow tie. So if you consider angle 2 and angle 4, angle 2 and angle 4, they're on opposite sides of intersecting lines here. They make a bow tie looking thing. Vertical angles make a bow tie. And the top one and the bottom one as well. Angle 1 and angle 3, you might have to turn your head to see the bow tie, but those also vertical angles. So angle 1 and angle 3 are a pair, and angle 2 and angle 4 make a pair. They are not adjacent. They're formed by intersecting lines, and they are congruent. They are congruent. Vertical angles are congruent, just like the sides of a bow tie are the same shape and same size. Now, what's important in geometry? We've seen a lot of things so far, and we are going to continue to see those things for the rest of the course. 4 things to look for: 360 degrees in a circle, 180 degrees in a half a circle, 90 degrees in a right angle, and congruence. Sometimes things add up to 360. Part plus part plus part equals 360. Sometimes they add up to 180. Part plus part equals 180. Sometimes they add up to 90. Part plus part equals 90. And sometimes they're congruent. Part equals part. You make the equation. You decide what's happening. Do you have parts adding up to some total, or do you have 2 parts that equal each other? Just about everything we do in geometry deals with one of these 4 things. You've seen a lot of it already, and we're going to continue to see more. So let's do some examples here. If the measure of angle 4 is 67 degrees, let's find the measures of all the other angles. So this here is a 67-degree angle. Well, I can see in the picture that I have a straight line right there. And those 2 angles form that straight line. That's a linear pair. And a linear pair is supplementary angles. So angle 3 and angle 4 add up to 180. So let's do that. Measure of angle 3 plus the measure of angle 4 equals 180. And I know that the measure of angle 4 is 67. I'll substitute that in and solve. Did you see what the equation was and how it related to what we said a second ago? Part plus part equals 180. We're seeing it already. 180 minus 67 is 113 degrees. So the measure of angle 3 is 113 degrees. And I also notice a couple of bow ties here. Angle 4 and angle 2, there's a bow tie. Those are vertical angles, and vertical angles are congruent, which means angle 2 has to be 67 degrees. And I also see a bow tie with angle 3 and angle 1. Those are vertical angles, and vertical angles are congruent there. So angle 1 is also 113 degrees. So we had a linear pair that was they were supplementary angles and added up to 180. And then we have several pairs of vertical angles that are congruent. How about this example? Measure of angle 1 is 23 degrees. Measure of angle 2 is 32 degrees. Let's find the measures of all the other angles. Well, I can see right here that I have a straight line, and a straight line has angles that add up to 180 degrees. Now this is 3 angles, so they're not supplementary. Only 2 angles can be supplementary, and they're also not a linear pair. Pair is also 2. We have 3 angles, but they still add up to 180. Angle 1, angle 2, and angle 3 have measures that add up to 180 to get that straight line. And since I know 2 of them, I can write the equation to get me that third one. So let's do that. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And there we are again. Part plus part plus part equals 180. Parts add up to the whole thing. Measure of angle 1, they gave us, let me fill this back in, they gave us was 23 degrees. Measure of angle 2 is 32. And we'll solve here. 23 plus 32 is 55, putting those like terms together. And then I'll subtract 55 Measure of angle 3 is 125 degrees. So that's 125 degrees. And then I can see vertical angles happening 3 times. Angle 1 and angle 4 are vertical. They make a bow tie. So angle 4 has to be 23 degrees. Angle 2 and angle 5 make a bow tie. They're vertical angles. So angle 5 has to be 32 degrees. And then angle 3 and angle 6 make a bow tie. So 125 degrees there. Vertical angles are the same, so we'll use those. That's congruent things, parts equal each other. And then if you're missing something, look for a straight line. Straight lines always have angles that add up to 180. Those 3 add up to 180. And it's not just that line. We could do this line. Those 3 also add up to 180. Or this line. Those 3 angles add up to 180. Doesn't matter where they are. A straight line has angles that add up to 180. Now, here's another example. We have this figure, and they give us the measure of angle 1 is 44 degrees. That's not up there, that's down here. 44 degrees. And the measure of angle 7 is 65 degrees. I also see a right angle box here. So let's see what we've got and use it. So I see right off that angle 1 and angle 4 make a bow tie. Those are vertical angles. So angle 4 has to be 44 degrees. And now you might think, okay, angle 7, is that a vertical angle with angle 3? Let's see. I have that line that goes all the way down, but then the other rays, that's not a straight line. This is not a bow tie. Vertical angles have to have straight lines on each side. So I can't use that. But I hope you notice a right angle box right there. Right angle is 90. So angle 6 and angle 7 make that right angle box. Measure of angle 6 plus the measure of angle 7 is 90. And the measure of angle 7 is 65, so I will substitute that in. Solve for measure of angle 6. And the measure of angle 6 ends up being 25 degrees. So that's a 25 degrees. And what else do we have? I think I noticed something here. Remember when I was trying to use angle 3? Angle 3 uses this side, which continues on over here. And angle 3 also has this side, which continues on down here. So while angle 3 is not vertical with 7, it is vertical with angle 6 plus angle 7. So angle 3 and this right angle are vertical. So that means angle 3 has to be a right angle. So I can go ahead and label that. That's 90 degrees. And there's a few ways of looking at what we have left. What I see is a straight line right here. And I see 3 angles that make that straight line. There's 180 degrees there. So I can add up 2 of them plus the missing one to equal 180 and find out what that missing one is. So if I have 90 plus 44 plus the measure of angle 5, that equals 180. These 3 angles add up to a straight line, 180. So that's 134 plus the measure of angle 5. Subtracting 134 from each side gives you 46 degrees. So this is a 46-degree angle. Part plus part equals 90 here. Part plus part plus part equals 180. And now vertical angles are congruent. Part equals part, 46 degrees for the last one. So look for what's happening. Do you have a right angle? They add up to 90. Do you have a straight line? They add up to 180. Do you have vertical angles? They equal each other. Find the rule that fits and use it. So these are some common algebraic equations used in geometry. We see these all the time. The parentheses, just pretend there's something in them. Sometimes when things are congruent, one part equals the other. That's what happens when things are congruent. Sometimes you have a part plus another part equaling some total. We do that with segment addition postulate. We do that with angle addition postulate. Sometimes part plus part equals 90. Complementary angles do that. Sometimes part plus part equals 180. Supplementary angles do that. So these are very, very common equations that we set up and solve in geometry. If you're working on something with a variable, consider using one of these equations. There's a very good chance that you will need to use one just like this. So let's finish with a couple of examples here. Two angles are complementary. The measure of one angle is 21 more than twice the measure of the other. Find the measure of the angles. This looks a little bit tricky because they don't tell me either measure. So I'm going to have to find two unknowns. Let's define them. X will be the first angle, and Y will be the second angle. These are their measures, of course. Now let's look at the clues. They're complementary. Well, complementary angles add up to 90, so I know that X plus Y equals 90. So now I have something I can work with. Now I can't solve this because I don't know what one of them is. So let's look at what else we have. The measure of one angle is 21 more than twice the measure of the other angle. There's an equation there. The measure of one angle, let's call that one X, is, that's equals, 21 more than. When it's 21 more than, that means I'm adding 21. And I'm going to have something plus 21. 21 more than twice. Twice, it's happening two times. I'm doing 2 times something. 2 times what? Twice the measure of the other angle. That'll be 2 times Y. So the measure of one angle is 21 more than twice the other angle. I've got the other equation now. So now I have a system of equations I can solve using algebra. I could pick a couple of methods here. I think substitution would be the quickest since I'm already solved for X. So let's use substitution. And since X equals this, I will substitute this in for X in the first equation. So where the X was, I am now going to replace it with 2Y plus 21. Plus Y equals 90. This was the X, but since X is 2Y plus 21, now it's 2Y plus 21. X plus Y equals 90. Well, now let's solve this. Combine like terms. 2Y plus Y is 3Y. Subtract 21. And 3Y is 69. And I can divide by 3. y is 23. Well, hey, now I know one of the answers. Well, let's get the other one. I could substitute this into either equation, and it doesn't matter which one you do, you'll get the same thing. What if I substitute it into the first one? X plus y equals 90, x plus y, well, y is 23, equals 90. Well, subtract 23, and x is 67 degrees. So now I have the two angles. They're complementary, yes. 23 plus 67 is 90, and one of the angles is 21 more than twice the measure of the other. 2 times 23 is 46, plus 21 is 67. So both equations work. That question is done. Write each equation, use the clues in the question to write the equations, and then solve the system. If a supplement of angles has a measure of 78 less than the measure of the other angle, what are the measures of both angles? So I don't know either one. So let's define the variables here. X will be the first angle. Y will be the second angle. I know they're supplementary. They're supplementary. Supplementary angles add up to 180. X plus y equals 180. So there's my first equation. Now look at the other clue. We have a measure of 78 less than the measure of the angle. A supplement of angles has a measure of 78 less than the measure of the angle. So one of the angles is 78 less than the other one. One of the angles, that's x, that's equals 78 less than. I'm subtracting 78. From what? It's 78 less than the measure of the angle. That'll be the other angle. So one angle is 78 less than the other. I've got my system. I can use substitution here just like the last one. Since I know what x equals, I'll take that and I will substitute it into the first equation. X plus y equals 180. Well, x is y minus 78. Plus y equals 180. X plus y equals 180. Let's solve. Y plus y is 2y. Put those like terms together. Add 78. And divide by 2. Y is 129 degrees. Well, there's one of the angles. Well, now take this, substitute it into either one. Let's put it in the second one. Either one works, but let's try the second one. X equals y minus 78. X equals y. Well, y is 129. 129 minus 78. Well, 129 minus 78, that's 51 degrees. So now we have the other one. They're supplementary. 129 plus 51 is 180. And one of them is 79 less than the other. 78 less than the other. 129 minus 78 is 51, so it checks out. So remember, all of your different angle types. Adjacents are like two slices of pizza sitting next to one another. Complementary angles add up to 90. Supplementaries add up to 180. Vertical angles make the bow tie, and they're congruent. And then just remember all the ways you can write equations. Do two parts equal each other, or do you have parts adding up to equal sum total? Set up the equation, solve it.